The history of the universe is spectacular. I often wonder, does the short life of ours really matter? Are we just a product of stardust? Or is there any significance or purpose to it? Welcome to the very first episode of the Grand Cosmic Story.
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
What do you feel when you look up at the stars on a clear night? Don't you feel an amazing sense of wonder within you? The infinite sky invokes a feeling of tranquility. As we stare at the twinkling stars, it is breathtaking to know that there is a lot more out there, even beyond them. The latest discoveries are changing our view of the heavens. Join with me in my journey to explore the cosmos, the galaxies, the stars and planets. We might encounter heat and cold, even fire. We can also meet aliens if they exist. To travel to the farthest reaches of the universe, we need to travel at the highest speed, the speed of light. The speed of light is almost 300,000 kilometers per second, 1,000,000 times faster than sound. With that speed, you can travel around the earth more than 7 times in just a second. But is it possible to travel at that speed? Let me explain. Assume that you are traveling on a jet plane and you are increasing your speed. When your speed increases to the speed of sound, you cause a sonic boom, a loud sound like an explosion. Now what happens if you are trying to still increase the speed to the speed of light? Famous scientist Albert Einstein says that you can never reach the speed of light using his equation E is equal to mc square. When an object moves faster, its mass increases because the energy increases. But when it tries to move at that speed of light, its mass increases to an infinite value. That is why no object can travel as fast or faster than the speed of light. Now let us suppose that we got a special space suit and a space shuttle that can travel at the speed of light. It's better that we take off from a place close to the equator where the rotational speed of the earth is at its maximum. That can give us a good head start. Join with me as we start our first cosmic voyage from Galapagos Island, right from the place where Charles Darwin got his idea that impacted the world of scientific materialism. Fasten your seatbelts. Remember, you are traveling at the speed of light. Let's first visit our next door neighbor moon and say hi. We reach the moon in just 1.25 seconds. Do you want to send a voice note to your friend from the moon? It will take 1.25 seconds to reach. Our next destination is the sun, which looks like a massive ball of fire. The distance between the earth and sun is around 150 million kilometers. That is equal to 1 astronomical unit. We need 8 minutes to cover this distance. The planet close to the sun is the smallest planet, Mercury. Next comes Venus, the morning star, the third brightest object in our sky. Our next destination is the red planet Mars, to which we have sent around 40 missions in search of the possibility of life on it, but Mars appears to be sterile. After Mars, we can see a belt filled with asteroids, many of which have hit us in the past. Beyond that, we encounter 4 massive giant planets that are mostly made of gas. They are Jupiter, the fastest spinning planet; Saturn, the planet with large majestic rings; Uranus, that rotates backward like the Venus; and Neptune, the coldest planet. Neptune is around 30 astronomical units from the Sun. Way past Neptune's orbit lies a region of chilly space called the Kuiper Belt. that holds Pluto, which was thought by astronomers as a planet. Even beyond the fringes of the Kuiper belt, beyond the heliosphere, we can find the spherical Oort cloud, the place of comet, extending a tremendous distance with its outer bound of around 200,000 astronomical units. Now we are entering into the interplanetary space, where astronomical unit does not make any sense. Let's now switch to the light year, the distance light travels in 1 year. This distance is around 9.5 trillion kilometers. The Oort cloud is 3.1 light years away from our sun. Now we are very far from our home, deep into the realm of trillions of stars and galaxies. The star closest to us is the Proxima Centauri, which is 4.24 light years away from us. This is a spectacular picture, a composite of thousands of pictures of our home galaxy, a spiral one, inside which our sun and all the planets are located. From its one end, if you want to meet your friend at the other end, you need to travel for 100,000 years at the speed of light. Andromeda Galaxy, the nearest major galaxy to us, is 40% bigger than our Milky Way, and it's at a distance of around 2.54 million light years from us. This is on a collision course with our home galaxy, the Milky Way. If we still move out, we arrive at the local group of galaxies. It's a collection of 54 different galaxies, including our galaxy, Andromeda Galaxy, and it's about 10 million light years across. This local group of galaxies is just a tiny piece of a massive structure called the Virgo Supercluster, which consists of at least 100 groups of galaxies like our local group, measuring a mind-numbing 110 million light years from one end to the other end. Recent study says that the Virgo Supercluster is only a lobe of an even greater giant supercluster called Laniakea Supercluster. Laniakea is a Hawaiian word meaning immeasurable heaven. Astronomers now say that Laniakea Supercluster of galaxies may even be part of a still larger structure that's still not fully defined. As we live in something called the cosmic web that has some areas densely packed with galaxies separated by giant empty spaces. This is the observable universe holding around 2 trillion galaxies, and its radius is estimated to be an unfathomable 46.5 billion light years. I believe what lies in the world that cannot be observed could be even more massive, of which our known universe is just a tiny slice. In 1977, we launched a spacecraft called the Voyager 1, which moves at the speed of 61,000 kilometers per hour. It's the farthest human-made object from Earth, and it's now around 21 billion kilometers away from the Earth. At some point in its long voyage beyond Neptune, Voyager 1 turned its camera around, took this photograph, this spectacular photograph ever made in the history of the world. Looking at this tiny pale blue dot, our Earth, Carl Sagan famously said, "Look at the dot.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives."
He concludes, "We float in this immense cosmos like a mote of dust in the morning sky." Stephen Hawking says more bluntly, "We are just a chemical scum on a moderate-sized planet orbiting around a very average star in the outer suburb of one among 100 billion galaxies. Our minuteness compared to the vastness of the universe can make some people feel insignificant." But is that true? Are we just a chemical scum on a moderate-sized planet floating like a mote of dust? What determines our significance? We say that an object has cosmic significance when it is prized as a valuable treasure, when it has intrinsic objective value. A newborn baby, though it's tiny, is extremely important for its parent. That determines its significance. I would like to end this episode with two life-changing questions for you to ponder. What is the significance of this tiny planet in comparison with the vastness of the universe? What is the significance of our lives which begin and end on this planet apparently without meaning? Think about this question of significance until we meet again in the next episode. Right now, many stars may be facing colossal death, but who is in control of this cosmic gate? What is driving the birth and the death of stars?